Hi, it's Dr. David Green, founder and CEO of R3 Stem Cell, the worldwide leader in regenerative therapies. Today, the topic is stem cell culturing, and we're going to use the whiteboard. That's why I'm standing in front of the whiteboard. So, what we're going to talk about is something that patients ask us about all the time now. And I'm impressed. Patients have gotten very smart, and I love it because they're really taking into their own hands, so to speak, making their healthcare decisions very smartly. So let me explain stem cell culturing. First of all, in the United States, you cannot culture stem cells and use them. All right, the FDA won't allow that. So in other countries, we do that. It's allowed. And basically what you're trying to do is you're trying to take a few stem cells and make a lot of them. But at the same time, you want to make sure that it's effective for patients. And let me explain how that can be a problem. So anytime you replicate cells, in this case stem cells, basically you're going from 1 to 2, and then those two make 2 more, and then you go on and so on and so forth. I call this potentially the Xerox Copier phenomenon, where what happens is initially when you make replications of cells, and remember from 6th grade biology, that's called mitosis, those cells look and function very, very, very similar, okay? But as you go more and more down and down and down, it's like a Xerox copier where they start to look a little bit different, right? They're a little bit fuzzier. You can really tell the difference between the original and the copy. And it doesn't, when the case of cells, they don't function at a certain point like the original. It becomes what's called senescent, which means non-functional, okay? So let's look at in the lab how this is done. If you're going to culture cells manually, and this is called 2D, two-dimensional culturing, you're going to put stem cells into flasks, right? This is meant to show the bottom of the flask. Now, stem cells love glass. They love to, attach to it. They love to replicate all through it. But at a certain point, they're going to reach the edges. Well, you can separate the stem cells from the glass using an enzyme like trypsin. And when you do that, you can then take those stem cells and put them into more flasks, okay? So when we talk about passages, a passage means you've taken stem cells from, this will be the first passage, and put them into a bunch of more flasks. That's the second passage. All right, and then when they've reached the edges on this passage, then what you can do is take them, and I didn't draw it all out, into a bunch more flasks, and that's the third passage, okay? You can keep going with that. The International Society for Stem Cell Research says that if you're going to use stem cells on clinical research for patients, you should stop at the 6th passage, or below. Because as you go more and more, they may be functional, they may be not, okay? So when we do our stem cell therapies around the world, we keep them at passage 3 or less, and once in a while we go to passage 4, which is fine, or less. Now this is two-dimensional culturing. I'm going to give you a math equation. Let's say you have, on 1 week, let's say we do 50 cases around the world. That's about what we do in any given week. So 50, and let's say each patient needs 100 million stem cells. What does that add up to? 5 billion stem cells. Obviously that's a lot. It sounds like a lot, and it is a lot, okay? Doing it this way, very difficult. You'd have to have these incubators that these flasks are in all over the lab. Most labs aren't big enough with their clean rooms in order to be able to handle that. So what do? Well, in our case, you culture from the first passage through the second passage, then you take these stem cells, just pretend there's a bunch of cells, right? And you can put them into a three-dimensional culturing device called a bioreactor. And what this is you see how it's a cylinder? On that cylinder, you put these stem cells and they attach to the substrate, which it could be any number of different substrates, but then this slowly moves and it stimulates, and then you add media and other reagents, and it stimulates these stem cells to replicate within the same passage, okay? Because you don't have to go to more flasks or more cylinders. So it maintains the functionality of those cells and the activity and the purity of those cells. So in essence, we can take, let's do an example, and this is real, by the way. We can take 5 million stem cells in, and what do you get out? Between 500 million and 1 billion. It's going to vary based off of how well they perform over that 5 to 7 days. 1 week, you can do that. So that's an overview of what passages are, what a bioreactor is, and we do this continuously in order to make sure that we maintain the quality and the functionality of these stem cells around the world. Visit us online at r3stemcell.com. Lots of educational information on there. You go to our YouTube channel, we have over 500 videos of education and patient success stories. All right, and then call us to get a free consultation for yourself or a loved one at the +1 844 GET STEM. Thank you.